Um, so yeah, I thought I would talk about my system. Now the camera's not going to work too well since I'm going to be looking down there and I can't look 90 degrees at the same time. I haven't got all this OBS thing figured out yet. Um, so yeah, so back in like so what was this? Circa 2013 is about when I started. 2012, 13 is about when I started kicking things around. 13 is when I started really kicking it around. And then in 14, I started making PCBs. Um, so my entire board set was called System Shock. I'm going to put some background music on really low. So way back, probably, yeah, 2014, I made a system, and I forget what the original name was, but it pretty quickly ended up being named System Shock. And the idea back then was Raspberry Pi control. People were trying to do crazy things. I think P-Rock was around, and I avoided P-Rock because the pricing was just insane. And I didn't like what they were doing or the way they were doing it. So I made my own. So we had a main controller board, and I'll show the other stuff. We had, so this did 128 switches. So two sides, 4 banks, 128 switches all at once. PIC32 microcontroller. Originally this was like error codes and things driven by, what's the size of that? That would be a World Semi 9-segment display driver, which I had dual. Yeah, so that quickly went away. I was like, I don't need that. So he went away. We have USB. That was purely to power the Raspberry Pi. Now this was back with Raspberry Pi 1, maybe 2. So we have a max 2 amp fuse, which I've jumped here. I'm looking at this thing upside down. So I've jumped the 2 amp fuse, but it was only designed to power, not for actual communication. Communication was all done through there. That's an RJ45 speaking RS485, which is a differential line communication driver. And I want to say it was running at 10 megabits a second, 10 Mbps. But yeah, so PIC32, this was the brains, 128 switches. It did all the control from this little guy here. And all communication went out. Now I have another version somewhere, which is dual RS485. And all these things will make sense when I show you the fast system. So this was the control board, Rev 1. I think it was really like Rev 3, because I only revved things when I fabbed them, and I didn't get every version fabricated. So we go from the master controller. What was next? Less interesting. I can't find my actual test board. I have one that's populated, and I couldn't find it. I only found the bare PCBs. This was the LED controller board. As you can see, RS485 in and out, so dual Ethernet jacks, which weren't Ethernet, but the cabling did full signaling. And this controlled 64 direct, was it WS2803s, RGB LEDs, not strings. There's a big difference in driving a string versus individuals. Now, you could actually drive you could chain 4 of these boards in one system. So you could have 256 individually addressed LEDs. Again, we have a PIC32 in the middle controlling it. And this is part of the reason why I stopped. So I had put in all this time and effort. You know, I'm a one-man show, hobby. These chips, these big Mux chips, they stopped making them. So I had to change the design. And then when I lost interest. So when I picked interest back up, COVID started. Everything's out of stock. I have to change everything on the design. I'm like, it's just not worth my effort. So this board is really the driving reason why I stopped building and developing the System Shock system. It was open source. I have all the things. I just never released it because I never fully end-to-end tested it to get it working. But these chips are no longer made, and you can't buy them. Mouser's got 0. There's none on eBay. I would have to redo the design. There's a similar chip in Surface Mount, and the whole point of this, all my boards were through-hole because it was like, sell the board. It's easy for someone to build. So if I went to Surface Mount, I was really going to compromise the design. And I didn't know because if I was going to do that, I could redo the whole thing in SMT. And, you know, these dip boards are huge. I could cut my PCBs in half and save a lot of cost. But then you're not talking Joe Schmo building their own system, populating boards, and I'd have to populate the boards, or, you know, use only parts that a fab house has, and I didn't want to go to that trouble. But this guy basically is the reason that I stopped. So we move on from the lead board to the smallest board of the family, the Raspberry Pi hat. Basically, you plug this guy onto the Raspberry Pi, and you get 10 megabits per second, RS-485 communication to all the other boards. Yeah, not much to say about him. Really simple, worked. Plug in your Ethernets, and away you go. That was probably the easiest board to make. Now we get to the board that saw the most revision, which I had probably the most fun making. This is the driver board. This is probably what does the heavy lifting. So this board is the driver. 32 solenoids, which is a lot more than everyone else's system is driving. So again, we've got dual RS-485 in and outs, controlled by a master PIC32, and it's running 4 banks of 8, giving you 32 solenoids all at once. The hardest thing, which never really worked right, was the watchdog, which is kind of important because you do not need a coil to stick on and suck 20 amps of power down at 60 volts and set your machine on fire. I never quite got the watchdog working properly. So that's one thing that even if I release this today, this would still need a revision. The idea is it should latch when it doesn't get a heartbeat from this guy. It'll lock the high voltage out and shut off all the solenoids. But what would happen is it would miss a heartbeat, it would turn off, and then the chip had a reset condition that would say, I've turned off for a second, I'm going to turn back on and just check. So then it would come back on. And there was no way to prevent the latch from just cycling. Now, as long as you fed a heartbeat, it stayed on. Everything worked perfect. But I couldn't latch it properly on a single use to stay off after that first time. I'm not a good enough electronics designer to do it, whereas I'm sure it's a really simple latching circuit. But I could never really figure that out. But 32 drivers was like, yeah, I don't need any more than that. You could actually chain 4 of these boards together. I don't know why you would need a pinball machine with that many solenoids. So the one I developed is better than everyone else's because it's more solenoids, meaning more things. Not necessarily. So this was the control board, which I talked about a little bit earlier, and it had 128 switches. So 128 switches, 32 solenoids. If you go buy a homebrew system, such as the Fast one, which we're going to look at, or P-Rock or P3, from a business perspective, what they do is great for them. From a client perspective, I disagree because, I mean, that's how businesses work. So what they do is they sell you a board. Hey, here's my 128 switches. Oh, we'll sell you a board that does 8 switches. How many of those do I have to buy versus one of these? Oh, you want 32 solenoids? Well, we'll sell you one that does 4 solenoids next to the 8 switches. How many of those do I need to buy? Like, the business model is, I'll sell you a dozen boards because you're gonna need more than just one. Whereas I wanted one system where 90% of your games could be made with one controller, one driver. But I'm not in a business, so my business model is different. And companies don't work the way I think they should, and that's about that. So now that COVID came around, the lead board, the chips were out of stock on the lead board. On this, I believe the drivers changed somewhat. They were really hard to get, these driver chips. These are special FET driver chips that instantly trigger the solenoids, because normally these FET drivers, you need to hit a certain amount of current for them to turn on and off. To do it quickly, you use a special driver chip. These got really hard for me to get during COVID. But that's the point where I gave up. With the lead board, the chips no longer being able to get. This needed a redesign, and this circuit, the latching circuit, just drove me crazy. I was like, I'm done. I'm not going to build my own system anymore. So the alternative to building a system is buying one. So I finally got off my backside and I bought one. So I have sitting next to me a box from Fast. And I remember having a conversation with Aaron, who runs Fast, a long time ago. And I never got around to doing anything. But this week, was it last week, I ordered it. So I figure it's time to actually stop moaning about it and get going with it. So let's do an unboxing of the Fast system. Knowing what I had built, we'll do a bit of a comparison. The difference being, Aaron runs a business and actually produced something. I'm a hobbyist. I didn't actually produce anything. So it's hard to complain when I didn't actually get stuff done. I'm going to get my anti-static wrist strap on. So this is the Fast controller board. I have not actually looked at any of these boards yet. So this is their second attempt at a control board. I don't know if it's Aaron that designed this or not. I'm not paying too much attention to chat. I apologize. So it allows you to make the whole circuit more compact. Well, my way of thinking would allow you to spend less money and have less boards which you needed to build out and build into your system. The new way of doing things, even Stern, it's all about small boards, using multiple of them instead of one gigantic board. You can't see here, I've got, off behind me, I've got 2 pinball machines. Those board sets, one of those is one gigantic board. Everything's on the one board. The newer machine I have, everything is split up on 3 boards, I think now. And that is, by comparison, even old. The newer systems, such as Spike, I think they're up to Spike 2 from Stern. It's all about little boards and a whole lot of them. And that's kind of the idea here that Fast have got. So you don't see a big array of switches. We do have our RS-485 jacks. I'm taking a guess here. I know the system is controlled through a UART, just a serial port. But I believe the controls through here, these are like sends and returns. I'd be pretty sure they're RS-485, but I don't know until I look more at the chips. But you have a USB over here, and your external PC will talk to that like an old computer talks to a BBS through the modem. This is just basically a serial line connection. You could have a Mac, a PC, anything. I'm going to use a Raspberry Pi. There is provision to use a Raspberry Pi on here. I don't quite know how that works. I have to look at their documentation. I don't know if you plug the Pi in here, if you still need to daisy chain into the USB, or the Pi's GPIO, I believe, will bypass the USB, but I'm not entirely certain. And then you also face the issue of when Raspberry Pi introduced the Wi-Fi chip, they changed their UART GPIO configuration for the worst. I say worst if you're using it for interfacing. If you're using Wi-Fi, it's great. So, and I don't know about Raspberry Pi 4, but I think it was the 3 when they did it. It had basically 1.5 UARTs inside, and they gave the Wi-Fi the good one, the complete one, and the port that you get on the GPIO here was given like the poor man's UART. There was issues with trying to use it at full speed or something. It's a long time since I dug into that. Many years, like probably 2014, 2015. I don't remember now. But I do know they had a problem. So I don't know how they've worked the pinouts for the Raspberry Pi on this. But my goal is to plug it in later and we'll take a look and see what happens. So what else we have on this board? So this here is, I don't know if I can get a tighter. shot. So we have, this is the expansion bus. So down at the bottom, you have node in and node out. So these two daisy chain to your like flipper boards and your switch boards. I want to say the next ones are your lights. The light bus, there we go. The light bus is on the expansion, these two. I'm not sure about DSP bus, but I believe the last two are your lights. What else we have on here? I haven't really taken much of a look at this. And these are, well, maybe these are your, I think these are your inbuilt string of lights. The controller board has one string of lights down here, and then you have 4-pin expansion buses for something. And one of mine has been bent in shipping, apparently. I'll have to bend that back later, but I probably won't be using that. Let's look at the other boards before I fire this one up and plug it in, and we'll poke at it and see what it does, because I haven't looked at any of these boards yet. Oh, so what do you get when you open the box? Let's zoom that back out. Yay, you're doing it. So they have a bunch of documentation. I haven't QR'd it, but I do know they have a bunch of documentation. And where's that? I did some Googling. They have some documentation. Some of it's good. I had questions. So I was looking at the schematics to try and figure things out. But I believe the QR code takes you directly to this. Get to know your Neuron. This is the Neuron controller. So yeah, when you unbox the starter kit, you get your thing. I'm not going to flip the pages because it's basically my name and address and what I paid and what's in the kit. But it's nice that you get a link to the documentation. And the starter kit, what else does it come with? We have a bunch of LEDs. Look at this. I left it up on screen. No one can see what I'm pointing to. There we go. So yeah. So one of those 4-pin headers, one of these 4-pin headers here, will drive 64 of these. And what do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are what, 40? We have 40 LEDs here. I don't know if I'm going to run 40 inserts, but could be used for GI. So that's nice. So that also comes in the kit. Let's see what's next. I did with each piece get the pins. Let's zoom back out. Just to make my life easier, I have all the matching connectors. These are for the power boards, I think. But you get all your plugs, your connectors, and the pins. You just got to provide your own wire. So I have all those. What's the next board in the system? I dislike this bubble wrap. If anyone from Fast is watching, I really dislike this sticky bubble wrap. And I would much rather see some kind of static bags. What do we have here? What does that look like on screen? I would say this is an expansion bus board. This has 4 ports. I presume, I don't know what that's for. I presume that's for maybe LEDs. It doesn't look like an LED driver. Maybe it'll make more sense when I look at the rest of the boards. Oh. Huh. Okay. So you get a bunch of these. These are, I would call these more like GI bulbs. But you can see they are the fast LED, their RGB LED system with a little plastic lens on the top. I would probably see that as more of a GI than an insert, but I don't know. So you get what, 10 of these? Yeah, probably about 10. I don't know where I'll use these though. I'd rather use the other ones. Or proper bulbs at least, anyway. What's the next board? This one's all sticky taped up and I don't have my knife on me. Let's see if we can get it open. I think this is the connector board. Let's put that out of the way. So I would say this one, I think this is your quick connect board. Does it say anything on it? Playfield interchange. So this would be, I would say, where you would, this would probably sit under the playfield and you would daisy chain from that into, say, the controller, which wouldn't be attached to the playfield. This would allow you to just disconnect all the RS Cat5 cables and lift the playfield up without disturbing the electronics boards. That would be my guess. 2 power filter, 2 coils. So yeah, this would be your daisy chain sitting between the playfield and your other boards, so you can quickly disconnect everything. Now, quickly disconnecting these, your Cat5s, piece of cake. Wiggling these off every time you want to do a disconnect would be a real pain in the backside. So I don't quite know how they envision people using that. So may or may not go into my system. I'll have to think about it. I'd rather not be trying to attach and detach Molex cables, especially, do these have the locks? Yeah, they do. So if you can kind of see they have like a P shape. So these are locking connectors, though, I mean, loosely locking. They won't wiggle themselves free and come a puff on the playfield while someone's playing. What else we got? We should have some control boards and things in here, if I can get the sticky tape off. So this is the I/O board, and this goes back to the business practice of running a successful business versus clients, right? So this has 32 switches, but only 8 solenoid drivers on it. So I don't know, like, what is the expectations with a board like this? 8 drivers. Now they have ones with more, but okay, 32 switches. That's not bad. I can deal with 32, but 8 drivers is ridiculous. I don't know. I just think the model is just kind of bizarre. But from a business point, it makes sense because now I have to go and buy, you know, a bunch of these. So we've got our Cat5 coming in. We've got our little microcontroller down there. I think that's our micro. We have our switch banks and our solenoid banks, or I'll call them solenoids, it's easier. But it has 8 drivers. We can drive 8 coils. Now they do make other versions. So let's see. I have one of the other versions in here somewhere. That's the power board. Let's see. This is kind of part of the reason I got really annoyed with P-Rock P3. It's because they were doing the same model. And I kind of get it, but from a customer perspective. So there's your alternative. This is your 1616. This makes a lot more sense. 16 switches, 16 drivers. Is it a 1616? Yeah. Like this to me makes a lot more sense. All right, so you plug in 2 or 3 of these. I don't quite get why you would maybe want 32 switches with 4 drivers. If I want switches, I don't necessarily want drivers on the machine, extra on the same board, right? But 1616 makes a lot more sense. And you're supposed to be able to have multiples. There's an ID header, but I'd need to take a deeper look. Yeah, 485 in, controller, line drivers. So I'd much prefer this board over the 32.8. And here's your big boy beast. This is your power filter board. Oh, that's nice. It's pre-fused. That's good. So what you do with this, and I believe this also has the interlock switches on here, or the interlock is on the controller, but the control passes through. You run all your voltage through this guy. You've got your 40 volt soils, 40 volt coil voltages, you 12 volts for your controls. Does it take 5s or is it just 40s and 12s? Controller, backbox, topper, CPU power, 12 volt CPU, 48 volt input. Okay. I'm not seeing 5s, just 12s and 48s. But yeah, so you got these caps. I'm guessing these caps are tied directly to the 48 volt line because firing your flippers, you want that juice right there. You want these guys to store it so it's always on tap, to give you that large amount in one go. So yeah, it's nice that it's pre-fused. Does it say, is there like a rail for each fuse? My eyesight's not that good. Well, I want to say that this one, I think they say the power board is optional, but I probably wouldn't advise that being optional. So I just have some connectors left in the box. But that is the starter kit. And I want to see what I optioned. So we got the starter bundle, the Neuron starter bundle, and I optioned the 256 LED board, which will be this guy. So I think that's the one I optioned. And then I added to it the 1616 because you only get, the starter kit only comes with the 32 switch 8 driver. So I've added 16. So I've got 24 solenoid drivers and 24 switches? No, 32 and 16. So 48 switches. So that might be good for switches, but I don't... hopefully that's enough drivers too. I don't know. We'll see. We're going to get some crazy with this design, or maybe a little bit. So, yeah. So one thing I want to do now is plug into this and get this connected. So I've got my bench power supply here, and I'm going to feed it 12 volts. We're going to connect to the I/O, to the UART port, and see what we get. So let's get that on the table. And so I've got a bench power supply sitting next to me. And I should be able to just power this thing up with 12 volts. Is my cable gonna reach? So I've got 12 on the high voltage on the yellow. So here they say, which is kind of, let's zoom in. We have positive and negative, which might not show up on the camera too well. Not ground and positive, positive and negative. There's our power. We have a barrel jack, which I absolutely detest. But we have pinned power, which would come from our power board here. One of these connectors is our power supply for this board. But we have plus minus 12. Yet over here on the back side, we have G for ground, not minus. So is this AC, positive and negative? Is that for AC? But then over here we have plus and minus. Like, Aaron, if you're here from Fast, be consistent with your silk screens. Is it ground or is it minus? I would rather see ground. I'm pretty sure it's just ground. But I would really like to see a bit of consistency there. Let's get that zoomed out. Alright. So, here's my power. I want positive. What do we got? The yellow pin is positive. So I'm going yellow and ground. Let's get you spare wire out of the way. Don't need you connected to anything. Alright, so if we power this thing up, we should see a row of LEDs light up, and I think this one might just blink. Alright, we got the good old GW Instech power supply here. Does that show up on camera? Kind of. So you can kind of see we've got our green LEDs and we've got our LED there. So yeah, so we're powered up, and to my understanding, it's all working normally. Now I'm going to flip this around and see if we can get a... And of course my power supply doesn't want to get that far. Let's see. I don't know if I can get this on camera right. Let's get these boards back in the box. That's about as good as I can get. So we're gonna use, I forget, I think, what is it, a micro? It is a micro B of all things, I think. I think that's a micro B. Let's get that plugged in. I have got an absolute mess of cables here tonight. I had to figure out how to try and get this on stream, because normally I just play games on OBS. I don't do anything like this. Alright. We are connected. Let's pull up the Raspberry Pi terminal. So I've SSH'd into the Pi. We need to get the... where did it go? Where's my edge? There is multiple UARTs on this thing. Alright, so we have 3 connections. Let's have a look. Yeah, alright, so the Raspberry Pi sees TTY ACM 0, 1, and 2. And I'm pretty sure we just want to connect to the first one. So that's by default what I created a Minicom driver. Minicom is just basically a UART interface, basically like a modem. Alright, we're in. So we're seeing XXF. I want to say from the small amount of Googling I've done through their documentation, that means failed command. It doesn't know what it is, but if we send an ID, we will get this board, which is the net, which is, if we connect it to a different COM port, TTY ACM1, I want to say that is the LED bus. I don't know if that is coming through on screen. Yeah, so I got so much going here. So yeah, I think port 1 or COM port 1 is the LED bus, and COM port 0 is your switches and drivers and so forth. So that's net, and the other one is EXP for expansion. So we're running CPU 2000, which I think is just the board ID, with firmware 2.06. All right. And I think CN is show nodes, of which there aren't any. Now, the program in me really hates this. So if you want to... So I'm going to write all the rules, do all my own code. I have to pass the CN return, which is fine if you just like, when you do the ID string and you get ID net FP CPU, if I get a list of that, I can pass that. No worries. If you spit out this garbage to me before I get to the data that I need to pass, that's terrible. So I don't know if there's another command that lists all the nodes. So why don't we plug one of the boards in, or 2 boards, and see if we can get the node list up. But if I have to pass this list that comes back from the CN reply, I don't want this inconsequential junk in front of the syntax that I need to actually decode. So having it pretty printed is really annoying. So I got to dig through their documentation and see if there is basically some other command that doesn't have this junk in front of it. Let's see if we can hook up... Well, I don't know if we can hook all of it up. Let's see what we can take here. So I'm going to zoom out for a moment and get that down there. So we have, I'm going to see if I can hook up the expansion, and I presume this can go directly into, well, this is a EXP bus, so it cannot plug into the node board, and I don't know what happens if I actually plug it into the node board. I don't want to find out tonight, so I'm just going to hook up the 2 driver boards. So we have the in port, so we're going to come in from that one, has to come out. So the out from the control board, and it's already running. So they're doing power over Ethernet, a form of. So I need to take this off. I have a whole pile of Cat5 cables, and I'm like, I don't need to try and do this little test setup with 10-foot Ethernet cables. All right. Let me undo my extra cables here. And I believe Fast will sell you cables. I did not buy them. I have so many Cat5 cables that for development, I don't really care about buying fancy flat ones. So we are going to go out from this board to the end of the next board and daisy chain them. This is like going back to when I did networking in the 80s, and we had like star networks and all the kinds of fancy stuff from IBM. But this just feels like a star network kind of deal, or a ring network, I should say, not a star network, because we're not going out and back, we're just going around the bus. So we're going to go out from our final board here to complete the circuit, and I have all this coiled up Cat5 cables here. So we're going to complete the circuit by coming back in and there we go. So won't see it off on camera, but we have some blinking lights on both boards. So we've completed our Cat5 circuit here. It's not Cat5, I shouldn't keep saying it. It's not networking cable. It is networking cable, it is not an Ethernet circuit. Right. So now when I do a CN, there we go. We have two boards. And again, we have this pretty printed stuff coming back that we have to ignore when we program, and I really don't like that. Ugh. But as you can see, we have two node boards in the loop. The first board we connected because they return results in the order that they are connected. So you can't really see it on the screen. I can't pan it out anymore. But the first board is basically what is reported. We see FPIO 3283. So that's just the code name of the board. We see firmware 1.09, SW 20. So all these numbers are in hex. 20 is 32. It has 32 switches. DR 8. It has 8 coil drivers. And then you get your serial number. The next board is our 1616. So we see FPIO 16163. Firmware 109. SW10. So 16 switches. DR10, 16 drivers. So we're gonna have to pass that in the app. When I write the app, we need to know the order of the boards is correct, because that changes the order of the numbering of your switches, I believe. Well, yeah, it does, because if you flip the boards, switch 3 is not going to be on the board you expect if somebody has gone in to fix something and accidentally rewired that wrong. So you've got to build in a lot of checking. It's fantastic that they return this. We can program that in and know. I just think that the pretty printing is a bit of a gotcha, and I don't know what else I'm going to run into now. But maybe the documentation goes over some other stuff. I don't know any other I don't have anything else wired up. I don't think I should wire up the expansion card just to see what happens, but I would like to read the documentation before I wire an EXP card into the net bus. I don't know what will happen. I don't want to find out on stream, basically. Maybe nothing will happen and it'll report like 0. But yeah, all the lights are flashing away and everything's going good. Interesting. I guess the next thing to talk about I wanted to go over is power. I'm going to shut this down and move it out of the way. I need a little bit of space. Let's shut the Pi down. Sudo shutdown H now. Alright. Pi is going to bed. And Neuron is down. Let's get the Pi out of the way. All right. Let's turn off the bench power supply. Let's disconnect these fellas. Oh, it's got covers on their snaps. I hate that. All right. We shall carefully put that back in the box for the moment. And I'll clean that up later. I'm going to leave the power board out because we're going to talk about power. I did not. When you buy the kit, let's pull it up. Let's talk about the kit. Bench multimeter, your cords are in the way. Alright. Let's pull up the kit because we can talk about that. So if we go to shop, we're not buying anything. I think I've spent enough money. Fast Neuron controller. There's the starter bundle. And one of your options is add power supplies. I did not add power supplies. You're going to need some if you buy this kit. So let's see here. Let's see. Little dusty. They've been sitting underneath my bench for a long time. We're going to need some power supplies. So, I have had these for years. Except for I got one not long ago. And I don't even know if they make... So let's put this out of the way. This is the big boy. I don't even know if they make this guy anymore. This is not the model. If you buy power supplies through Fast, this is not the model they sell because I believe the SE is no longer a thing. This is the SE 648. So we've got 48 volts. We are putting out 12 amps. Because we're a USA 120 vac. So we're putting 12 amps out at 48 volts. It does not look like this. If you buy, so mine, we have our AC in on the front. And then when you turn it around, we have our outs. The new model that their website sells is, I think, like the next iteration of this. It's 48 volts. I think it's less amperage. But I want to say the power connector at the back is continuous. It's not like mine where it's split. This is a big boy. He's chunky. He weighs a lot. Genuine Meanwell, good. They make really good power supplies. You have to be careful that you do not get a clone or even a fake Meanwell. This I actually bought through Meanwell, and the lady was like tickled pink that I was building a pinball machine. Now we're talking 2015. I actually had to go through a few people, but I bought it directly from them because there was no easy way to get these back then. Now I think you can just get them on Amazon. But this is the 48 volts. This is your high power for your coils. You need this. Basically, yeah, all your coils, motors, magnets are all going to run off this guy. So it needs to be good and stable. So this has got 12 amps of power. No, that takes input. Well, we actually do have 12 amps output. Input out, yeah, 12 amps. So we're good for 12 amps. He'll power our coils, no worries. You need 12. You need 12 volts. What have I got here? I have one that I actually made a video on. Genuine Meanwell power supply. And I wasn't too happy with it at the time, not realizing something. So I should clear that up right now. This is the QP 200 3D. This has 4 outputs because I was using this for another project. You'll see up here, I'm upside down and it doesn't work. We've got 5 volts at 10 amps, 3.3 volts at 15, 24 at 4. Now I made a video where I put this under a load test, and it can only supply so much power in total. So you're not getting 15 amps of 3 volts and 10 amps of 5 volts and 4 amps. Like, you're going to get a combined total, but if you're not also putting these outputs under load, you're going to get some wildly strange results. You're not going to get the output wattage that you expect. You can't just use this and power 3.3 volts and be like, I'm going to get 10 amps, because you're not going to get 10 amps. It's not going to work. But I'll come back to this one. So, Meanwell are going to sell you a version of Meanwell. Fast Pinball have in their kit a version, maybe the model below this. This one doesn't say at the top. This is the LRS 35012. So we have an output of 12 volts at 29 amps. So basically 30 amps, 12 volts. Why on earth do you need 30 amps? Well, you don't, but, and I believe the one they sell you is 10 or 15? I don't remember now. But the one they sell you is adequate. What do you need these for? All your LEDs will suck the juice. If you're going to start stringing LEDs, you're going to need 12 volt power. And it needs to be good and stable. You'll notice he has a fan. I believe the one that Fast sells doesn't. I don't know for certain. If you're hitting a lot of amperage, you want some good cooling. Like this thing, the 48 volt has a fan at the front. This other one, we have another fan in here too. This other one I'm going to show you is just an open cage, no fans. But you do need some movement. And this one is not a Meanwell, but Meanwell make open cage power supplies. So you need a really good, strong 12 volt. This is a single output. Basically, we have a bunch of ground and a bunch of outs. So single voltage, like the 48s. Not like the mixed output of this one. So you need those two at a minimum. and that should cover everything you need. So I need one more. What's this one? Output 24 volts. So this is a single output. It is not a Meanwhile power supply. Who makes this? RS. This is Delta. So I want to say that this is actually TDK Delta. They are also used to make great power supplies back in the day. This is not some random Chinese brand. So why am I pulling out this for 24 volts? And this also has 24 volts. Because, where is it? We've talked about coils. We've talked about, drivers and switches. We know we've got a Raspberry Pi. What does the Raspberry Pi got to do? It has HDMI out. It's going to drive video. Fantastic. Where is your sound coming from? So my goal there is, it's only small. And it's old. This is a PCM 2704, I think. 1704. It is a simple USB to 2-channel analog DAC. Runs 96 kilohertz. Pretty good fidelity. Better than old PC sound cards, that's for sure. But super simple. Oh, my music is kicked up. But you've got to get some amperage to drive things like this. This is the soundboard I'm going to use to drive the speakers and the sub. At minimum, it'll take 12 volts. You're not going to get good results out of these boards running only 12 volts. It will take a maximum of 25, I believe. Doesn't say on the board. But we're running dual TDA amps, one for each speaker. The sub on this is a crossover, but I don't know if I'm going to do that way. You really want to push the voltage not to its maximum, but which I think is 25 on these boards. These boards are like $5, or they were when I bought this. I don't really need bass, treble, etc. I just want a volume. But this will do our sound and not even blink and break a sweat. But we really want to give it like 24 volts. And the good thing is, where is it? So this is our 24 out. And you might see there's this little pot just down there. So we can actually slightly undervolt this 24 volt output, because to me 24 volts, like the limit on this thing is 25. At 24 we're awfully close at that higher rate that I wouldn't want to go that high. Not that I don't trust it. I'm saying maybe I don't trust it. I mean, it's a $5 Chinese board. What are the caps? I cannot see. There's no... They are... It says Rubicon. I don't know, I believe that at all. And they're rated for 25 volts. They are right in line with the power jack. You do not want to run 25 volts. Like, I wouldn't want to push this thing at 24 volt, but maybe undervolt it a couple of volts if I can. This will be fine. So I need a third voltage output for sound, and that should give me everything I need. So I've got to wire up 3 of these honkin' power supplies. So I've been thinking about that too, because that's like the first thing I want to do is build up the power bar, because that's going to drive everything. That's going to feed into this, and this is going to be part of the heart of it. You got to have good stable power, and I'm going to have a bus bar. I've got the, where's my, I don't see it. Alright, so yeah, I've got bus bars, I've got the EMI filter. We'll run that straight after the IEC socket. We've got our honkin' big switch turning on and off. We've got the bus bars. So I think one of the first things I would do is build out a little development box of just, I'm going to have 3 power supplies stacked in a row, which you can't even see on camera because I can't zoom out far enough. But we have 3 of these to daisy chain. We're going to have to daisy chain hot, neutral, and earth off the bus bar through the EMI filter to these, and then from that, I don't know if I'm going to bus bar between the PSUs and the power board, because all your power board, this is supposed to come from here. So I may bus bar after this just to easily distribute the voltages off here rather than before. Now I think that's kind of obvious. I'm going to have to bus bar it after for distribution to make it easier. I don't know if I can find them now. I have a whole bunch of these brackets because apparently, meanwhile, power supplies are so common now that the screw mountings have their own bracket size. So this one has a low mount, and I don't know if the 48s are the same. That they look further apart than this one. I won't even be using this one. That's the multi-tap unit. Where's my single? There's my single. I don't think they're the same width. They're not. But if I can get one, if one is the same, I don't have my calipers handy. If that distance, I don't know if that's the same distance or not. So these have these little wings, and they just slot right in, and look at that, pretty much the same. No, you don't want to go in on that side. Interesting. Maybe some bending with the pliers and you will get in, but you are slightly out of dimension, but otherwise we could probably force that. But you'll work. But you will not for that one. Ugh, dropped him. Okay. Oh, it's a long way down. So, power supply box, Raspberry Pi 2. I think that about sums that up for steps. And we'll see how it goes. See you next time I do a pinball stream. Hopefully you can come by and we have a little more to talk about than boards on a table. But yeah, I will catch you all next time, and thanks for hanging out.